Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Basicity of nitrogen and oxygen-containing compounds depends on the availability of the lone pair on the heteroatom for donation to a proton, H+. Moving on to the next step. A. Pyridine. The nitrogen lone pair is in an sp2 orbital, not part of the aromatic pi system. It is available for protonation, but the sp2 hybridization means the lone pair is in a more electronegative orbital, making it a weaker base, pKa of conjugate acid (5.2). B. Pyrrole. The nitrogen lone pair is part of the aromatic pi system, contributes to electrons to the 6pi electron aromatic system. This lone pair is delocalized and therefore not available for protonation. Pyrrole is an extremely weak base, pKa of conjugate acid (-3.8). C. Tetrahydrofuran. THF. The oxygen atom has lone pairs, but oxygen is more electronegative than nitrogen and a much weaker base than nitrogen compounds. D. Pyrrolidine. The nitrogen is sp3 hybridized in a saturated 5-membered ring. The lone pair is in a pure sp3 orbital and is fully available for donation to a proton. sp3 nitrogen compounds are stronger bases than sp2 nitrogen compounds. The pK of the conjugate acid of pyrrolidine is (11.3), making it the strongest base among the options. Moving on to the next step. Pyrrolidine, sp3N, lone pair fully available. Pyridine, sp2N, lone pair available but in more electronegative orbital. THF, oxygen, more electronegative, weaker base. Pyrrole, lone pair delocalized into aromatic ring, essentially non-basic. And for the final step. A. Pyridine is less basic than pyrrolidine because sp2N holds lone pair more tightly. B. Pyrrole is the least basic because its lone pair is part of the aromatic system. C. THF is less basic because oxygen is more electronegative than nitrogen. Therefore, the correct answer is D. Therefore, the correct answer is option D.